Alright, in this lecture we are going to talk about collision resolution techniques. Now before continuing to resolution techniques, let's one more time identify what's collision. Now let's say we have these strings over here and we want to insert them into this array over here. Now we know from previous lectures that the step over here is we need to convert these strings into integers which will be used as a cell index in this array over here. Now let's say when we apply a hash function on these strings over here, every time we get the same integer number. So let's say when we apply hash function for the first string, we are getting index of 2. So we are going to insert ABCD to the index of 2. Then we are going to call hash function for this second string over here. Now when we are calling it, we see that one more time the output is 2. So this means that if we want to insert it at the index of 2, it's going to cause collision. So in this case we have a collision over here. Now the collision means that the cell is already occupied over here, so we cannot insert this string to this cell over here. Now the question is, how can we solve this problem over here? So to solve this problem, we are going to implement resolution techniques. So we are going to learn resolution techniques in this lecture. So given collision can be solved by using two different ways. Now the first way is direct chaining and the second way is open addressing. So we are going to learn them separately and we are going to implement them separately. So here you can easily see that in case of open addressing, we have linear probing, quadratic probing, and double hashing. So let's get started with the direct chaining. First we are going to learn direct chain and we are going to implement it in practice. Then we are going to continue to learn open addressing and we will learn all these three types of open addressing over here and we are going to implement them in practice. So in case of direct chaining, our hash table is not an array of integer. Instead, it will be an array of references. It means in every cell of hash table over here, we will store the reference of the linked list. So we are going to implement it using linked list. So let's say we have strings like this and we want to insert them in this hash table over here. So here again, one more time, the first step is we are going to call hash function and we are going to find the index of these strings to be inserted in this array over here. Now in this case, we are not going to insert the strings in the cells over here. In the cell, we are going to have only references. So first, we are going to call hash function for the first string over here. Now the first string is ABCD. So if I call hash function for this string over here, we see that it's going to return 2. So this means that the reference of this string will be stored at the index of 2 over here. Now in case of direct chaining, as I mentioned before, we are using linked list. So this means that we are going to create a node and assign this string to this node over here that we are going to create. And we are going to save at the index of 2 the physical location of this node over here. Now when we create a node in case of linked list, the node will be look like. So when we are creating a node, we are going to assign ABCD over here and the next reference of this node is null because in this case we don't have any other node after this node. Now the physical location of this node is 111, so this means that 111 will be saved at the index of 2 over here. Now after saving it, it's going to create a link from here at the index of 2 to do this node over here. Now then we are going to continue to the next word. Now in the next word we have EFGH. Now if I call hash function for this word over here, it's going to return 2. So this means that we have to insert EFGH at the index of 2. But here at the index of 2 we have another node over here. So this means that we are going to create a new node and we are going to link this new node to this node that we have in the index at the index of 2. So when we create a new node, the next reference of this ABCD will be set to physical location of the new node that we created over here. So here with this, we have easily created a link between ABCD to EFH node. So in this case, you can easily see that if the values that comes from hash function are same, we are just adding this node at the end of this linked list over here. Now if I call for this string over here hash function, now one more time you see that it's going to return 2. So this means that here again we are going to create a new node and we are going to update the next reference of EFH to the physical location of new node over here. So the physical location of this new node is 333 and we are updating the next reference of EFGH to the 333. So with this we are creating a link between EFGH to this new node that we created over here. And it continues like this until the limit that we set in our code. Now if I call for example for one more string over here, Miller string, the output will be 7. Now in this case this means that we are going to create a new node and assign Miller to this new node and you see that the physical location of this new node is 444. So we are going to add this triple 4 at the index of 7 over here. So with this, we have successfully inserted Miller in this hash table over here. So that's how it continues in case of direct chaining. So this means that in case of direct chaining, we are not inserting the values directly to the cells. We are just inserting reference of node to these cells over here. And if we have same value, we are just going to add at the end of this linked list over here. So this is how direct chaining prevents collisions in this case. Now, based on this logic, let's head over to Java and create direct chaining class and implement insertion, searching, and deletion methods for the hash table that we are going to create over there. Now here, I'm going to implement direct chaining resolution technique. So to do so, I'm just going to create a new file over here, and I'm going to name it direct chaining. So inside this file, we are just going to create our class over here. Now, before creating class, as I said before, we are going to use linked list and array list over here. So that's why I'm just going to import array list and linked list from Java util library. So it's going to be like this. Import java.util.arraylist. I'm just going to copy this code and put it over here for linked list. Now, after doing so, we are going to create class which is named direct chaining. So it's going to be like this. Public class direct chaining. Then inside this class, the first thing that we are going to do, we are going to create hash table, which will be the array list, and it's going to be the type of linked list. Because as we said before, in the cells, we are just going to keep references of linked list. So this means that in the cell, we will have linked list. So the type of hash table should be the linked list. So it's going to be like this. Linked list string, because in the nodes inside linked list, we will have the string. So that's why the linked list type is string. And it's going to be the type of array over here. And I'm going to name it hash table. Now, the next thing that we are going to create, we are going to create the maximum size of chain. So as we said before, we are going to set the limit to be inserted at the linked list, because if we have inserted many elements at the linked list, then the time complexity will be O(n). So to prevent these cases, we are going to put limit in this chain size. So it's going to be max chain size is equal to, for example, for simplicity, I'm putting 5. So it depends on you, so you can select whatever you want. Now, after doing so, I'm just going to initialize hash table with fixed size. So in this case, I'm just going to put over here inside constructor something like this. So it's going to be direct chaining. So as a parameter, I will put integer over here for the size. So this will be the size of the array. So inside this one, we are going to initialize our array. So hash table will be equal to new linked list with the size that we are getting from this parameter over here. So with this, we have successfully created our hash table over here, and we have initialized it with a fixed size. Now then, the next thing that we are going to do, we need to have hash function over here. Now for simplicity, I'm just going to create hash function that we have explained in our previous lectures, which was using ASCII values. So in this case, I'm going to declare it like this. Public int. So it's going to return the integer value, because in this case, we need output cell index. So that's why it's going to be the integer. So the name of function will be mod ASCII as we created before. So I'm just going to put it mod ASCII hash function. So this function will take two parameters. Now the first parameter is the string that we want to insert. So I'm just going to put it as word. And the second parameter will be integer, which will be the number of cells in the array over here. So it's going to be m. Then here, I'm going to create character array. So it's going to be like this. Then I'm going to convert this word to the character array over here and assign it to the character array that we created over here. So it's going to be like this. Word.toChar array. Then I'm going to create another variable, which will be integer and sum. This will be used for loop, and inside loop, we are going to sum up the ASCII values of these characters. Then we are going to find the mod of this sum over here. So it's going to be like this. For sum is equal to 0 and I is equal to 0, in this case, it's going to continue until I reach the length of the word that we are inserting. And in each time, it's going to increase by 1. Now inside this loop, we are going to sum up the ASCII values of characters. So sum will be sum is equal to sum plus I. Now with this, after summing up, we are going to sum up the ASCII values of these characters that we have in this word over here. Now after doing so, at the end, we are going to return the mod of these values over here, sum mod m. which is the number of cells in the array. Now with this, we have successfully implemented our hash function. Now then, I'm going to continue to implement insert key in hash table. So in this case, we are going to call hash function, and after finding the value of the string, then in this case, we are going to insert it to the hash table that we have over here. So our method will be like this. Public void insert, I'm going to name it insert hash table. So this is going to be take one parameter, which will be the string, and the string that we want to insert, which will be the word. Then inside this function, the first thing that I'm going to do, I'm going to find the index of this word. So we are going to find index of this word by using hash function that we created over here. So it's going to be like this. Int new index is equal to, we are going to call hash function, and in this case going to be the first parameter going to be the word, and the second parameter will be the length of the hash table. So it's going to be like this, hash table dot length. Now with this, we have calculated the index of this word that we have got. Then we are going to check that if we have a value at this index, then it means that we are going to create a new node and add it at the end of linked list. If we don't have any value in this index that we found over here, this means that we are going to create a new node and we are going to add the physical location of this new node to this index at the hash table. So it's going to be like this. If hash table with new index is equal to null, so this means that we don't have any value in this cell over here. So we are going to create linked list in this cell over here, and we are going to add the value to the linked list over here. So it's going to be like this. Hash table with new index is equal to new linked list with the type of string. Then we are going to insert this word to this linked list over here. So we are going to use add function of the linked list. So it's going to be like this word. So by adding this, we are just creating a linked list in this cell over here, and we are adding this word to this linked list over here. Now after doing so, we have successfully inserted a word to this hash table over here. Now in the else condition, otherwise if we have a value in this cell over here, so this means that we are not going to create a linked list because it's already created. We are just going to add this word at the end of this linked list over here. So one more time, I'm just going to call hashtable.newindex.addWord. So with this, we have successfully inserted this word to this hash table over here. So this is implemented in case of direct chaining. Now to make our life easier, I'm just going to create another function over here which displays the values of hash table. So after insertion, we can easily see that what value we have in each cell. So by using this function, we are just going to see the values. So here I'm just going to create a new method which will be responsible for displaying hash table. So I'm going to name it like this. Public void display hash table. So it's not going to take any parameter. We are just going to print out the values from this hash table over here. So it's going to be like this. If hash table is equal to null, it means that hash table does not exist, so we are just going to return. Otherwise, we are going to loop through the values of hash table and printing out them to the console. So it's going to be like this. If hash table is equal to null, we are just going to print out to the console saying that the hash table does not exist. So it's going to be like this. System.out.print hash table does not exist. Then after doing so, we are going to return. Otherwise, in the else condition, I'm going to put something like this. So first, I'm going to print out something like this hash table. I'm just going to copy it from here and pass it over here. So inside this one, I'm just going to put something like this. Then we are going to loop through the hash table. So it's going to be like this. For I is equal to 0, and I will continue until hash table length, and it will increase by 1 in each step. Then we are going to print out something like this. System.out.println. So first we are going to put index plus I, it will show the index, and then we are going to put key, so we'll easily see that which key we will have in our hash table, and then we are going to print out hashtable.I. Now after doing so, we have successfully implemented display hash table method over here. Now let's see how this is working in practice. So in this lecture, I have just implemented hash function and insert hash table. So in the next lecture, we are going to implement source function and delete function. So here, let's see how insertion method works. So here inside main class, I'm just going to create an instance of direct chaining. So it's going to be like this. Direct chaining is equal to new direct chaining with the parameter of, let's say, 15. So because we have to set size, Now after doing so, I'm just going to call insertion method for this direct chaining. So it's going to be like this, insert. So I'm just going to copy the insert hash table method from here. And for example, the first thing that I'm going to do, I'm going to insert the article, then I'm just going to copy it a few times. So the next word that I'm going to insert is quick. Then I'm going to insert brown. Then I'm going to insert fox. Then at the end, I'm going to insert over. Now after insertion, I'm going to call display hash table method to see the output in the console. So this makes our life easier to understand it very well. So in this case, it's going to be like this. Well, let me just copy the name of the method from here and pass it over here. So it's not taking any parameter. So let's run our code. Now you see that after insertion, it's printed out to the console the values that we have inserted over here. So as you can see, after calculating the hash value for D, we have got 4, so that's why it's located at the index of 4. Then for quick, we have got 1, so that's why it's located at the index of 1. Then it continues like this. So here you see that we haven't got any collision, so that's why it has inserted them in the separate cells over here. Now instead of 15 over here, if I put 13 over here, we should have collision over here, because in this case, quick and fox words results the same index, so both of them are resulting at the index of 8. So this means that we are inserting them at the same index in the linked list. So as you can see, quick and fox words over here are located at the same index. So with this, we have prevented collision in this case by using direct chaining. So with this, we have come to the end of this lecture. So in this lecture, we have implemented insertion in hash table in case of direct chaining. Now in the next lecture, we are going to implement search method and deletion in hash table in case of direct chaining technique. So see you in the next lecture.